Alright, so let's go ahead and start Chapter 3 over solving equations. And let's start with Section 1 where we're going to solve with just one-step equations. So there are a couple of pieces that I want to make sure we focus on in this solving category. So when we see that word solve, we know that we're going to find out an answer. And that answer is going to be the value of the variable. Because usually, I like how this is written here. To solve an equation is to find out the value of the variable. This requires work by us because the variable usually has numbers around it, preventing us from knowing what it is. Hence, our job in solving is to get the variable alone so we can figure out its value. I really like that idea of getting the variable alone, and that's really our goal, is to find out what number belongs in that place, because that variable is really just a placeholder. Now, we're coming back to some Chapter 2 topics here, this idea of being an inverse. Inverse operations are the ones that undo one another. Addition and subtraction, multiplication and division. So, that idea of undoing. Equivalent equations. This word equivalent we're going to come across an awful lot over the next year or so. And when we see equivalent, we should always be thinking that they are the same. That word equivalent is the same. So equivalent equations are equations that have the same solutions. The addition property of equality is to do with those inverse operations, that adding the same number to each side of an equation produces an equivalent equation. In other words, you are allowed to add a number to one side of the equal sign as long as you also add it to the other side of the equal sign at the same time. Great paragraph. Great few sentences to explain this. Remember, whatever you do to one side, you always have to do to the other. Do it on the left, you have to do it on the right. The same thing applies to subtraction. You can subtract the same thing from each side as long as whatever you do on the left, you have to do on the right. To the left and to the right. Left and right. Keep them the same. They always stay the same, then you stay good. So there's a question here. Why might we want to use the addition and subtraction properties of equality? Well, to solve an equation. Now I know that you already can look at this problem, right? Y plus 3 equal to 10. And you can jump all the way to the bottom down here and you could say, oh, well, y has to be 7 because the only number that gets added to 3, or gets 3 added to it, is equal to 10. So we know the answer is 7, but that's not what I'm worried about in this chapter, because I know there are lots of ways to just know the answer. My worry is whether or not you can communicate with me and tell me how you found your answer. So that in this problem, y plus 3 is equal to 10. The inverse operation to addition is subtraction. So we're going to go ahead and subtract 3 on the left, because then we would have y plus 0. Whatever I did on the left side of that equal sign, there's that balance line, right? Whatever I do on the left of the balance line, I also have to do on the right. So that y plus 0 is just y. And that balance line represents your equal sign. 10 minus 3 is 7. That's where our work came to. Alright, so let's look through these questions. Look at that side of the side that the variable is on. Is the variable alone? No, it's not. We can see that it has plus 3 with it. That's what's in the way, that plus 3. And it's how is it connected to the variable? That's kind of like thinking about what would you do if you knew the variable, what would you plug in, or what would you do to the variable? And we would add 3. What can we do to cancel it out of the left side? We already did that. We subtracted 3. And we're allowed to do that because of the subtraction property of equality. Then we simplify. And then we check our answer by substituting it back into the original equation for the variable. If it's a solution, it should make it a true statement. And we already talked about the fact that 7 plus 3 is the only way to get that 10. Go back in and fill in these questions. So when we look at this, I know, it just kind of blipped up. So that when we look at this, make sure you've got all of your answers recorded. And I would also like you to take a moment. Remember, understanding the why behind all of this will help explain. And if you always understand the why, you'll always know what you're doing and the reason behind what you're doing, so that you'll always have an idea. When we see the directions, solve for the variable, we should be thinking, get the x value alone. Undo anything that's connected to it. Go ahead and try these 4 problems. I think you'll be okay on your own, but this last one I'm going to explain after you've had an opportunity to try them. So, give them a try. I wanted to interrupt, and I want to make sure that I point out to you that I'm still using that balance line because it's going to keep me organized. Anything I do on the left, I also have to do on the right. On the left, I'm trying to get x all alone, so I subtracted 5 because positive 5 and negative 5 give me a 0. Whatever I do on the left, I have to do on the right. X plus 0 is x. 11 minus 5 is 6. All right, keep trying them. All right, so here are your 4 answers. And I want to remind you, and I want to bring your attention to this 4th problem, because this is probably the one that students make the most mistakes with. And I want to remind you that the sign that's in front of a number is the one that goes with it. So that this is a negative 4. And the way to make it into a 0, its inverse would be to add 4. So we needed to add 4 to both sides of this problem. Be very cautious. That's where a definite common mistake happens. It's not about what's happening in the problem. It's about what the number is and how to make it into that 0 in the case of addition or subtraction, that additive inverse number. Let's go to the next page. Now we're going to talk about the multiplication property of equality.